Describing the graph, really you're going to use a calculator, so that's going to pretty much do it for you. You're going to identify the number of zeros looking at it. Later on, we'll talk about how to actually find the zeros, but we're not going to do that yet. So hopefully you can see this guy here. So if I'm going to do, if it tells me describe the graph, I'm just going to type that into my calculator. I'm going to go to the y equals, and I'm going to put 3x to the power of 4 minus 7, and then I'm going to look at the graph, and I'm going to see what happens. So this actually didn't show me enough of what happened. I have to zoom out, and I'll tell you why in a second. And I'm never even going to be able to see it. This is a pretty bad example. The 4, what this 4 means is that there are 4 changes in 4 different directions that it travels. Let me show you on something that you know already. So if we said y equals 3x plus 1, this is an exponent of 1, and you know that this is going to be a graph that just looks like this. This is only traveling in one direction. If I make it this, 3x squared plus 1, you already know what's going to happen. It's going to go like this. And this is traveling in 2 directions. It's coming down, it stops, and then it goes up. So this exponent tells me the number of different directions that it travels. So since this one's a 4, that means that on my graph, I really need to have 4 different directions. So it's going to go like this. It's going to go 1, 2, 3, 4. Something along these lines, okay? Now, how do I know which direction it opens? Well, remember back to your quadratic. Quadratic, if this a value is positive, then it opens upward. And the same's true with these guys right here. Because this is positive, it's going to open upward, okay? So I would describe this, if I was describing it, I would say starts on the top left. I'm going to write that down here. It starts on the top left, travels down, then up, down again, and finishes going up. That tells me that it has this many different changes in directions, and that's what's showing me. That's what I'm looking for you to tell me when you're telling me this, okay? Now, my graph that I drew, it never crossed the x-axis, so the number of zeros would be none, but that's not actually true. I just did a really bad drawing that. So we want to do it on the graph so that we can see the zeros, okay? I'll show you another example. So let's say that I have f of x equals negative 4x to the 4th plus 6x to the 3rd minus 3x squared. Okay? Since this is negative, I know that it's going to go like this. It's going to start going like this. It's to the power of 4, so it's going to have 4 different changes. 2, 3, 4. So it's going to look like this. Now where it crosses, I don't exactly know. But I know it's going to look like that. So let's put this into the equation. Negative 4x to the 4th plus 6x to the 3rd minus 3x squared. Put it in the wrong. Negative 4x to the 4th plus 6x to the 3rd minus 2 minus 3x squared. And we're going to look at the graph. I might be zoomed out too far. I'm going to zoom in a little bit. I still can't really see it, so I'm going to zoom in again. It looks like my change in direction is right here. So I'm going to actually zoom it in just a little bit more. So it's coming up, it changes down, it changes up a little bit, and changes down again. It's kind of a funky example, but that's what we're looking at. So you can see the difference. Changes in directions are kind of right there. And that's it. That's what you're looking for. It looks like this only has one real zero. It crosses right there. So one real zero. That's it for these guys.